This is the project, which is basically a BCD Adder circuit, which performs the BCD addition of two input BCD numbers, each of one digit. So this is the switch from which we input the BCD, and this one is the second input, and the input is displayed on these two 7-segment LEDs after it is decoded using 7448 IC. And then this is 7483, which adds these two numbers, and after this AND OR logic checks if the sum is greater than 9. If it is so, then this 7483 4-bit binary adder adds 6 to the previous sum, and then it is decoded using the 7448 IC, and finally it is displayed on these two 7-segment displays, which is connected with the aid of this single 7448 IC. So this is the basic introduction to this project, and the application of this project. This basically, I mean to say that this BCD adder is that it is used in computers and the calculators that perform arithmetic operation directly in the decimal number system. It is found in ALU, arithmetic logic unit. Now let's move on to the simulation or the circuit diagram of this circuit. This is the circuit diagram of the project made on Proteus. Now let's have a look on the major components used in the construction of the circuit. Starting with this 7448 IC, which is a BCD to 7-segment decoder. This one is also 7448, and this one right over here is also 7448. This one is 7483, which is 4-bit binary adder. This one is also 7483, 4-bit binary adder. And after that, this over here is AND OR logic. These are the major components, and obviously these output LEDs. These are the major components used in the construction of the circuit. And the inputs are given from these two dip switches, which are grounded to prevent the floating inputs, and then this input is also given in this decoder, which then displays the output after decoding, and then after the same process occurs over here, and then the input also goes to, as you can see, it's also connected to this 4-bit binary adder. These two digits are added, and then you can see the connections that this is connected to this AND OR logic. Alright, so this AND OR logic checks if the sum is greater than 9. What it does is that this 7483, what it does is that it adds 6 to the result, and then it decodes it, and finally the result is displayed on the 7-segment displays. So that how it works. Summarizing it, this portion over here is the input portion, and this middle one, including this 7483 and this portion, this is the processing portion, and finally this is the output portion. The output is displayed over here. So that's basically it. Now let's test the simulation. I'm going to run it, and for example, if it's 6 and 2, the result is 0. If let's say I do 1 0 and 0 0 1, 0 0 1 1, it's 3, and if let's make this 7. So 7 is 0 1 1. 7 plus 3, it gives us 10. So this is the carry LED used to display the carry. 7 plus 3 is 10. So in this case the carry is 1, so this LED is activated. So this is working pretty fine. After understanding the working and seeing the Proteus simulation of the project, let's finally test the circuit out. As we can see that when the input is 0 and 0, the we can see zeros on the 7 segment, and the result is also 0. If I do 1 plus 3, let's say, so it gives us 4 on the output display. And if I do 9, if I do 9 and 1 gives us 10, and 9 and 9 gives us 18. This LED over here, it indicates that the carry is generated 1, as you can see over here. If I do 1 plus 1, it's 2, so there's no carry, and the output and the LED which indicates the carry is off. So that's it. Thank you.